All right, so let's talk about implicit differentiation. First, I just want to remind you of these two forms, explicit and implicit. So explicit form of your equations would look like this, just the regular way, to y equals 2x plus 3, or y equals sine of x plus the square root of 3x, and so on. So your equation is written in terms of x here. Now, that's explicit. Implicit, when you have something like this, for example, x squared plus y squared equals 3, or xy minus 3 equals 7. So that would be the explicit form. Now, in order to find the derivative of your implicit form, that's easy. So all you have to do, for example, in this case, when you have y equals 2x plus 3, you simply do, well, you take the derivative of 2x and you get 2. Derivative of 3 is 0. So your answer is 2. Or in this case, when you have sine of x plus the square root of 3x, if you want to find the derivative explicitly, all you have to do is take the derivative of sine, you get cosine. Derivative of square root of 3x is 1 over 2 square root of 3x, but we have to apply the chain rule and multiply by the derivative of 3x, which is 3. So let's just put it on top. So that's it, nothing fancy. But it's a different story when you have to deal with implicit differentiation. And let me just give you one example here. Now, one more thing. When you find the derivative of, explicitly, I'm sorry, like in this case, in this situation, we set dy dx equals 2, right? So therefore, dy we can say equals 2 dx. All right. Now, let's see what happens when the symbols don't match up. I'm going to use a new page. So, for example, let's say we have y squared, and we want to find the derivative of y squared. Well, the symbols don't match up, right? You have dx or y squared, as opposed to dx and, for example, x squared. And that's easy. We know that the derivative of this would be 2x. But what do you do if you have to differentiate the y squared? The symbols do not match up. So look what I'm going to do. Just a little simple trick. I'm going to multiply by dy over dy. I'm allowed to do that, right? And I still have that y squared. Now, I'm just going to take this part right here, which is dy, and put it right next to y squared. Now you see the symbols match up, right? But we also have dy dx sitting right there. So now you can find the derivative of this since the symbols match up, and you can just take the derivative of y squared and you get 2y. But you can't ignore this part, so it's just times dy dx. And now you're done. You just took the derivative of y squared. Now let me show you another example. Without proving anything, I'm just going to show you how to differentiate, for example, y squared equals 2x plus 3y. And you noticed we have an implicit form here, so we have to apply implicit differentiation in this case. So this is what the procedure is. We're going to differentiate both sides at the same time. Now, remember, since it's y squared, it's not x squared, so the derivative of y squared is going to be 2y, but remember what you put right next to it? That's right, dy dx. Derivative of 2x, well, that's just a regular derivative. Explicit form, that would be 2. Plus, the derivative of 3y. think about this. Derivative of 3y. The symbols don't match up, so you have to go through that process again. So if you remember, what's going to happen is you're going to take the derivative of 3y, you're going to get 3, and then you're going to have dy dx sitting right there next to 3. So that's where we're going to put 3, and immediately dy dx. Well, we're looking for the derivative, right? And the derivative we can find by isolating dy dx, which is y prime, the same idea. So what am I going to do? I'm going to probably move this guy right here to the left, which means subtract 3 dy dx from both sides, and have 2 on the right side. Now we can factor out dy dx, and we get 2y minus 3. And now in order to find dy dx, we simply divide both sides by 2y minus 3. Now we're done. I hope this makes sense. Let me show you another example. Let's say we have 2x plus e to the power of y equals x squared minus y squared. So we're working with y and x. We're working with applying implicit differentiation. I'm sorry. So same thing. We're going to find the derivative of the left side, find the derivative of the right side, and then see what happens after. Derivative of 2x, that's easy. It's just 2. Derivative of e to the power of y, remember, so we're applying implicit differentiation, right? So derivative of e to the y is going to be e to the y. But we have to put what? Immediately, dy dx right next to it. Equals. Derivative of x squared is 2x, nothing fancy. Derivative of y squared, another one. It's 2y, but dy dx. Some people prefer, instead of writing dy dx, some people just put y prime, which is fine. Okay, now we're going to isolate these guys. So it's going to be e to the power of e to the power of y, dy dx, plus 2y dy dx equals 2x, and this guy right here is going to move to the right, which means we have to subtract 2. Now we're going to factor out dy dx, and we get e to the power of y plus 2y equals 2x minus 2. And the rest of it is easy. You just divide both sides by e to the power of y plus 2y. And now you're done. I want to show you one more problem that requires the implicit differentiation. Derivative of sine. Well, we all know the derivative of sine is cosine. However, we have to apply the chain rule because it's not just sine of x, it's sine of x or y. So we're going to multiply by the derivative of, I just want to set it up first, and derivative of xy. Plus, derivative of square root of 3y would be 1 over 2 the square root of 3y, but we do need to multiply by, we're applying the chain rule again, 3y prime, equals. The derivative of 5, it's just a constant, and that would be 0. Let's continue. Cosine of xy times. Now we are dealing with a product rule here. So it's going to be x prime y plus xy prime. And then the rest of it, I'm just going to put the 3 on the top in my numerator. But when you take the derivative of a 3y, you have to, what? Put dy dx. That's the implicit differentiation, right? You put the dy dx next to it. Equals 0. In other words, once you touch your y, when you find the derivative, just you think of dy dx immediately. So you have to put that one. We get cosine of xy times. Now, derivative of x is 1. So all we have left is y. Plus x times, but derivative of y is 1, but we're differentiating implicitly, so it's going to be 1 times dy dx, right? Plus 3 over 2 the square root of 3y dy dx equals 0. Now, we have to isolate the dy dx, but this is a little bit complicated. In this case, we do need to get rid of the parentheses. So we're going to actually distribute the cosine of y. Now let's see what happens after. So we get, I want to put this y first, otherwise it's going to look weird. Y cosine xy plus, I'm going to put x dy dx first, times cosine xy plus 3 over 2, the square root of 3y dy dx equals 0. Now you see we have dy dx here, we have dy dx here. So we can actually factor out, but this guy right here, we can get rid of it by subtracting y cosine xy from both sides. So we're going to get dy dx by itself. We're going to factor out, we just pulled it out. So we have x cosine xy plus, here we have 3 over 2 square root of 3y, and then equals, remember this guy, move to the right, becomes negative. We get that. Now all we have to do is just divide both sides by this long expression. I'm going to erase the top part of my problem. So we get dy dx equals, we're dividing negative y cosine xy by whatever we have in the parentheses here. Now, you can manipulate a little bit, you can simplify more, and I don't really want to talk about it right now. If it's free response type of question on your IP exam, you don't have to do anything. You can just leave it like this. But if it's a multiple choice, obviously you have to work with your options and see which one matches your answer. If you don't see anything, then you have to probably do something here. And that's about it. I hope this makes sense. Let me know if you have any questions.